So this slide gives examples of um, future value annuities. So again, annuity is a stream of equal payments to or deposits to be made or received at some point in the future. So in this case, it's $2,000 a year. So uh, 20 years at 8%, that grows to 91,524. If we extend that 30 years, due to compounding, uh, grows to $226,566. If that rate increases to 10%, the amount grows an additional $102,000. So, and then if it's 14%, that amount grows to $713,574. I have on the right hand side, I have the Excel solution. So this literally, if you went into Excel and just clicked on a cell and typed equals FB 0.08 20 comma 20 comma 2000, that's telling the Excel that you're investing $2,000 each year for 20 years at 8%. That what you should get 91,524. I believe there will be some change, and so on down the line. So for 30 years at 14%, it'll be 0.14 and 30, and then comma, then 2000. The nice thing is when you go into Excel, if you type in equal FV and open paren, it actually tells you what to enter in that register. So you can hit FX and it will give you a register where you can simply type those in, and I'll show you that when we work examples. So, the next slide shows what those investments look like over time. So over up to 30 years. So the $2,000 a year invested in each year for 30 years. Again, just like with the lump sum, due to compounding, that slope becomes steeper and steeper over time. Slope increases over time, even with the lower rate, due to compounding. All right. So next we have present value. So present value of a lump sum. So that answers the question: what is the equivalent value today of dollar amount to be received in the future? Present value, or PV, equals the future value divided by 1 plus the rate to the power of the number of periods. That's the basic formula. So the present value of annuity, what is the equivalent value today of a series of payments to be received in the future? Suppose you want to have $30,000 a year for 20 years during your retirement to supplement your expected pension payments. What amount would you need to have invested at retirement to reach that goal if you can invest your money at 7%? So in Excel, it would be equals PV, 0.07, the rate, 20 is the number of payments that you want to receive, and then $30,000 is the amount of the payment. So you would have to have $317,820. Okay, so concept checked. So 2 common time value money questions. What will investment or series of investments be worth after a period of time? That's a future value. we're referring to compounding here. So when we talk about a present value, we're discounting. So we're either compounding or discounting. Compounding is adding on, discounting is reducing. So so present value, how much has to be put away today or as a series of investments to provide for some dollar amount in the future. This question asks for the present value. So what's the difference? Next, we have what's the difference between simple interest and compound interest. Why is it critical? Simple interest doesn't pay interest on interest. It's the interest. You don't get the interest until it's you withdraw the money. So compounding interest refers to interest on interest. So the compounding is the best way to build wealth over time. With compounding, grows, your money's going to grow faster. So, all right, so that's the end of the actual lectures. Next one is a continuation of the concept check, and we're going to work problems for future value of lump sum, future value of annuity, present value of lump sum, and present value of annuity.